Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Anilen Sindane. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center, broadcast by Phakama Research and Development. I hope you had a restful holidays. Our topic for today is financial mathematics. In our question paper, finance has 15 plus minus 3 marks, and the subtopic for today is the grade 10 and 11 financial maths, which is our growth and decay. That in our grade 12 paper has 5 plus minus 3 marks. The other financial maths involve annuities, and we shall do them in due course. Our lesson objectives for today: at the end of the lesson, you should be able to understand the difference between simple interest growth and compound interest growth. You should understand the effects of the different periods of compounding growth and decay, and this will include our effective interest rate and nominal interest rate. We should be able also to use the simple interest decay and the compound interest decay, which are given by the formulas that you know, to solve problems which involve straight line decay and reducing balance depreciation. Now we can refer to our CAPS document on page 26, 38, and 42. That will be the content for our grade 10, 11, and 12 that we know. And then for our examination grade lines for grade 12, we refer to page 6 for the 2021 examination guidelines. Now, we should be knowing, as you are aware, we are using lots of formulae. Our substitutions must be correct. Our knowledge of functions, because we are going to link our compound growth and our simple interest growth to the functions that we have done. We should be knowing how to manipulate our formulae, changing the subject of the formula. Literal equations, we did them in grade 10, and we should be having them in our fingertips. We should be able to interpret our word questions and put them into equations. We should be able to understand our conversions, because we shall be doing it. And we should also be able to use our logarithms and exponents, because we will meet exponential equations that will require us to solve for an exponent or something that will require us to use logarithms. Now, for our simple interest growth, we'll just take you a little bit back. We know that interest is calculated on the original amount, and the interest remains constant over the period of time. You will see this as we move along. Compound interest, we know that interest is calculated on the original amount plus the interest added to each time interval. You will see the difference. Now, let's look at the formula for simple interest and the formula for compound interest. Now, for simple interest, it's given by A is equal to P1 plus I to the power, 1 plus I times N. We close the bracket. It's more of a linear equation. Our A represents the final amount, which is accumulated at the end of the investment period. P represents the original amount, or our starting amount, which is the principal amount. I represents the interest rate per period, and N represents the number of periods where our interest is going to be earned. Now, you should be knowing that the I is normally given as R over 100. Hence, I said to you, we will also be doing conversions because our R is a percentage and we have to convert that percentage to a fraction or a decimal before we substitute it into our formula. That is very important. Also, simple interest, we use it a lot when we are looking at things like hire purchase. Our interest is normally calculated using the simple interest formula. It was done in grade 10. Hopefully you have managed to revise it again this year. Compound interest, also known as the inflation formula. Our formula is it's an exponential form. A is equal to P1 plus I bracket to the exponent n. Now, A and P and I are the same for our simple interest and compound interest. Our n also is the number of compounding periods. You will see that this will change. For our simple interest, please note that our n is always given as the number of years. But for our compound interest, you will find out that it depends on the compounding that we are dealing with. We are going to discuss more on the compounding part, but n does not represent number of years when it comes to compound interest. It will only represent the number of years when we are dealing with inflation, because that is the one that is calculated in years. But you will see as we answer the questions the difference. Please, let's move on to the next part. We are given that Peter invests 1,000 rands for a period of 5 years at 12% per annum simple interest. Calculate the value of Peter's investment at the end of the 5 years. Now, remember, I said to you, we are going to be dealing with lots of word equations. We must understand the scenario first, and before choosing the formula, because these formulas will be given in our formula page, but we need to use the correct formula at all times. So we are able to see that we are having 1,000, and that 1,000 represents our principal amount. That is the amount that is invested. Then we are also having the period, which is 5 years. And we are able to say for the period, we said this will be our n. It's 5 years. Then we have got 12% interest per annum. I have said for us, we are substituting I, and we know that I will be given by 12. We convert 12% as a fraction is 12 over 100. As a decimal, this will give us 0.12. Now, we need to find our A, which we do not have. We are going to now use our simple interest formula, do the substitution, and get our final answer. So we are going to do it that way. So our A is equal to P1 plus n times I bracket. So I'll substitute for my P, I've substituted 1,000. 1 plus my n, I've substituted 5, and for my interest, I've substituted 0.12. You punch this on a calculator, you get your final answer as 1,600 rand. So we must try and save. You will realize that our interest For the first year, we used P times R over 100, which is given by 1012 over 100, and we got our interest for the first year as 120 rand. And we are saying for our simple interest, this interest will remain the same every year. First year, they will receive 120 rands as the interest. Second year, they will also receive another 120 rand interest. But what will be the amount in the account? We can illustrate this using the table below. So you will realize that at the end of year 1, the investment was 1,000. We got an interest of 120 rand. So at the end of year 1, the amount that is in the account is going to be 1,120. That money remains in the account. Following year, end of the year, our interest becomes 1,120 plus the 120 interest for the second year, and that will mean at the end of the second year, the amount in the account will be 1,240. This will continue. Year 3, as illustrated, you are adding 120 to 1,240. That gives us 1,360. End of year 4, it will be 1,360 plus 120, and that will give us 1,480. Year 5, we get 1,480 plus 1,120, and that will give us a total of 1,600 rand. You can see that using the table and using the formula, we are getting the same answer of 1,600 rand. So sometimes we'll be asked how much interest was earned. We know that to get the interest that is earned, we are going to say it is the final amount minus the principal amount, and we can say this investment of 1,000 over a period of 5 years earned an interest of 1,600 minus the principal amount, which is 1,000, and that means the interest earned over the 5 years is going to be 600 rand. Now, that is very important, because as we grow or we give our brothers, our sisters, and our parents advice at home, financial advice, we should be able to understand some of these investment opportunities that people come across, and we should be able to use our financial maths knowledge to help them choose the correct investment options so that they get value for their investment. Now, if I look at this, we are able to plot, for example, we can plot a graph, year 1 versus year 2 versus the amount that is in the account, and you will realize that when you plot a graph for this one, it will give you a straight line graph like that. We start with our 1,000 year 1 at T0. We have year 2, year 3, and then we put our amounts this side. You'll find if we start with 1,000, we'll go to 1,120. You will have a point there at 1,120. You have a point at 1,240. And when you join these 2 points, you will find out that the relationship between the amount in the account and the time, which is the years, will give us a linear relationship, and that will be a straight line graph. You will realize this. Now, you are able to see that the interest that is calculated at the start of the investment is based on the money that they will invest and will remain the same. I've bolded that one so that you see that the interest that is earned each year, it's always constant. It does not change. Remember, linear graphs, what is the common property, the points that I have plotted here, they will all be collinear because the gradient will remain the same. And between any of the 2 points will remain the same. Hence, we will have a linear relationship. We move on to the next example. I've used the same example for Peter, but now this has changed. It's now compound interest. This is what we should always be doing when we are reading these financial maths questions. You must be able to interpret the information that is given and you use it accordingly to help you answer the questions correctly. Our P still will do the same thing. We'll get our information. We're getting our P is still 1,000 Rand. Our period, it's 5 years. So that will be our N for this example. N will be equal to 5. Our I will be 12 over 100. Remember, we change this from a percentage, or if you are using your calculator, you can punch it as a percentage as it is. And then you or substitute it as a fraction or as a decimal 0.12. And then because of the compound interest, we write down our formula. A is equal to P, 1 plus I to the power N. And then we substitute our A, substitute our 1,000. I've made it 10,000 there. I've cancelled that part. 1 plus 12 over 100. Our calculator has a fractional button. We don't need to stress converting to decimal. And that will give us our exponent as 5. We have our exponent button on our calculator. We press equals. We will get our solution as 1,762,34. So it means when Peter uses the compound interest investment, they are going to get 1,762,34. You are able to see that the period of Peter's investment using simple interest is 5 years. Using compound interest, it's also 5 years. But somehow, he is getting more money using compound interest. Now, can you explain why? Just think for a moment. The interest is the same, the principal amount is the same, the period of investment is the same, but we are not getting the same answer. What could be the reason why our A using compound interest formula is 1,762? The one that we got earlier on, we got our A as 1,600. So there is a difference of 162,34 rands. Can we account for that difference? Yes, I know you know the answer, because we know that the graph of an exponential function is not the same as the graph of a linear function. Now, when you try to represent this information, you will realize that on the first year, the interest end, we are using the formula I is equal to P bracket R over 100. We will put our 12 over 100 there and we'll get an interest of 120. At the end of year 1, the amount that is in the account, it's 1,120 rands. That becomes the principal amount for the second year. And you will realize that the interest end at the end of the second year will be 134 rand 40 cents. It's no longer the 120 that we said, that we got for the first year. So the interest keeps on accumulating because our principal amount will change. Whatever is the final amount at the end of the first year becomes the principal amount for the second year. whatever is the final amount at the end of second year becomes the principal amount on the third year. And this continues like that, as illustrated in that table. And that is how we'll end up having an answer of 1762.34. Again, I will ask you to plot the relationship between the amount in the account at the end of year 1, year 2, year 3, and year 4 and year 5. You will realize that you will have something like that. Here we are having an amount. We are starting with 1,000 here. Year 1, year 2, year 3, year 4. Year 1, we had 1,120. It's a point just above there. Year 2, we are having 1,254. And you will find out that the graph that you draw will take a shape like that. I know my space is limiting, but you will have more of an exponential growth like that. And that is why our final amount will be 1,762, and on a straight line, we got 1,600. So that gives us a bigger return for our investment. So you will realize that if the principal amount is the same, the investment period is the same, the interest rate is the same, you will find out that when you invest with compound interest, the return will be more than that of simple interest. We move on now to the next part. So there is the explanation that for the compound growth plan, interest is recalculated every year based on the money that is in the account. And the interest will change every year of the investment. As you can see, I've illustrated it in red, that the interest keeps on changing. Again, if you plot the interest year 1, year 2, you will find that you will not get a straight line graph, but you will get an exponential function there at the end. Now, I will give you 3 minutes to answer that first question for me. 3 minutes. Let's answer that activity 1. Remember, you read the question, you identify the keywords, you extract the information that can help you solve that problem before substituting into the correct formula. 3 minutes, let's answer that question. Right, welcome back. I forgot to tell you that you must have your calculators and your pens ready close to you because we'll be doing these activities together. I cannot just be saying things out. We learn through doing. Now, let's look at the question together. You'll realize that Rita wants to have 8,000 in her savings account at the end of 48 months. If she earns 9.6% simple interest, these are the keywords that you must get. Look at this, 9.6 at the end of 48 months. You must underline the keywords. That's our principal amount. How much? Determine how much must she initially invest. So it means right now there is nothing in the account. She still needs to decide how much should she put in the account so that at the end of 48 months there is 8,000 in the account. So let's get the information we have. Our A is equal to 8,000 rands. Our I is going to be 9.6 over 100. Our N, there's a story there. Remember, this is simple interest, and we said for simple interest, our N has to be the number of years. Here we are having number of months, so we must know our conversion factor so that we get our years. We know that in a year there are 12 months, so it means to get our N, we must divide that 48 by 12, and that will give us N as equal to 4 years. And our unknown in this case is our P. We do not know our P. Then we are going to use the simple interest formula, and we should get, as you can see there is the information. We have our information on the other side, and we are going to substitute into the formula, and we are going to change the subject of the formula, and we should get our P, which is our principal amount, as 5,780.35. So it means if Rita wants 8,000 within the next 48 months, they should invest 5,780.35 today, so that after 4 years, this amount will be 8,000 rands. So please, we should be able to manipulate our formula so that we always look for what is wanted. Our calculator has fractional button, so we shouldn't stress when we are answering these questions. Manipulate, rearrange your formula, make whatever you have as your P the subject, and then do your manipulation at the end and get your answer. Remember, we round off the final answers. The other steps, we shouldn't round off for accuracy reasons unless the figure becomes too much for you. But let's try by all means to minimize rounding off too early, otherwise we introduce errors to our solutions. We move on. Now, let's talk about compound interest. I have explained this using the example and the table that our interest is calculated on what is in the account. It's not only given on the original amount that is in the account, it changes all the time. And we know that there is nominal interest rate, and this can be calculated for the given interval. For example, now we are going to be having terms like the interest is compounded annually, it's compounded half yearly, it's compounded monthly, it's compounded quarterly. So you will find out that our nominal interest rate will always change, and as it changes, we get what we call the effective interest rate that we'll get for the whole year. We will discuss it later. Right, so with nominal interest rate, there is a change to N and I. As I have mentioned, if our interest is compounded monthly, you will find out that we'll divide our I by 12, and then to get our exponent, we'll multiply the N, which is the number of years, by 12. Quarterly, we divide our I by 4 and multiply our N by 4. Half yearly, semi-annually, biannually, these are the terms that you are going to be seeing. Or interest is compounded every 6 months. You will find out you divide your I by 2 and you multiply your N by 3. If it's compounded daily, our interest is divided by 365 because we are having 365 days in a year, and our number of periods will be given by the number of years multiplied by 365 to give us what we will substitute there. Now, so these are the terms that we should also be looking out for. For monthly interest, it can be every month or monthly. Quarterly, it can be given as every 3 months. We know that there are 4 quarters in a year. That is why we are saying quarterly, we divide our I by 4 because there are 4 quarters. So it means the interest will be awarded 4 times after every 3 months. So if they say the interest is compounded 3 monthly, you know that you are dealing with quarterly. So these are the terms that you should be aware of as I mentioned them. Now, we are going to be working with nominal interest rates, and we are also going to change the compound interest formula a bit to accommodate the nominal interest and the changes in N and I that come with it. So you'll realize that the formula now becomes A is equal to P1 plus I over M, and our exponent becomes N times M. Now, you will know that our A is the final amount. It hasn't changed. Our P is the principal amount. N is the number of years there. And our I becomes the interest rate. And M becomes the frequency at which the interest is calculated. You saw in the previous slide, for monthly compounding, our M will be 12. So, for example, if the interest is compounded monthly, this will change to A is equal to P1 plus whatever we have as our I over 12, and that becomes our 12N, and then we will substitute accordingly. We move on now, and we are going to have this activity. I'll just give you 2 minutes to check if you are following what we are discussing. We are given that Jody invests 8,270 for 3 years at 7.5% per annum, interest compounded monthly. Determine the value of Jody's investment after 3 years. Let's try it. 2 minutes. We learn by doing. Right, welcome back. I will go through the process again. We read and understand the scenario. So the first part, we are given Jody invest. This is our principal amount. N is going to be 7.5% per annum compounded monthly. That's our M. Determine the value of Jody's investment. So I'll quickly write them down. Our P is 8,750. Our N times M will be equal to 3 times 12, and that will give us 36. Our I over M, that means our I, we can convert it and write it as 0.075 over 12, or alternatively, we can substitute it as 7.5 over 100 times 12. This will give us 1,200. You can punch this on your calculator. It will still give us the correct solution. Now, we are using the formula A is equal to P1 plus I over M to the power N times M. And we'll do our substitution and our answer will quickly come out. So that's our solution. And we should get 10,950,15 at the end of 3 years. Remember now, we said N is the number of periods or the number of times that the interest is going to be awarded. So for this particular question, every month interest, a certain interest percentage is going to be awarded. So that is why you will find out that we are dividing the interest by 12 and multiplying the number of years by 12, because the interest will be awarded 36 times in those 3 years. Every month interest is awarded. That at the end of the month, whatever we have as our principal amount is the one that is going to help us become the principal amount for the next month, and so on and so on. And that will give us our solution as such. Now, so sometimes you'll be asked to calculate the monthly interest rate. So in this case, the monthly interest rate, it's what we get as our I over M there. So it means the monthly interest rate becomes 0.07 divided by 12, or 7.5 over 12. That will be your answer. If you want to convert it to a rate, you multiply it by 100% and you'll get your answer there. We move on. There is this concept that we call the effective interest rate, and I hope you have seen the formula for it. So the effective interest rate is the compound interest that is compounded for the whole year. It's calculated for the whole year. If you are compounding the interest every month, if it's 12% per annum compounded monthly, it means whatever the investment accumulates will be actually more than the 12% that is given for that particular year. Remember, we have said for compound growth, the growth is exponential. It's not linear. It's not always the same amount that is accumulated. That is why we have that exponential growth. You will realize that the nominal interest rate, it's given by I to the power M, or in some instances is given by I subscript norm. So it's just a way of trying to differentiate the two. We have a nominal interest rate, we have an effective interest rate. So that is for naming purposes. And you will realize that our M, we know that is the period of compounding. So we should be able to convert between nominal and effective rate. Sometimes you'll be given a nominal interest rate and then you are asked to calculate the effective interest rate. You must be knowing how to do that. Sometimes you'll be given the effective rate, then you are required to calculate the nominal interest rate. You should be able to manipulate the formula to help you do those calculations. And you'll realize that the effective interest rate is given by bracket 1 plus I nominal over m all to the power m minus 1. Or the formula can be given like that. So that will give us our effective interest rate. It can be given either as the first part of the formula or the second one that I've indicated there. So you should be able to use either of the formula, because you'll realize that the one on the left, which is red, it's just, we have just transposed this one to the other side. That is why it is like that. But the two formulas are the same. It's a matter of just manipulating the terms from the left-hand side to the right-hand side. So I've explained the formula. Now we should be able to use the formula. Now let's check. We are supposed to find out which investment is better, is the better interest rate for saving. We are having two, there's 9%, 9.5% per annum or 9.2% per annum compounded quarterly. So in this particular case, we are going to use our formula as I've illustrated above. So 9.5% per annum, this becomes the nominal interest rate, which will be effective at the end, because this is the interest that you are going to earn for the whole year. And then we have got 9.2% per annum compounded quarterly. This 9.2% is the nominal interest rate because of this compounding quarterly. We must get the effective interest rate. So as illustrated, I have used the formula 1 plus I nominal over m to the power m minus 1. So I've substituted. Remember, our interest has to be a percentage, a decimal, or a fraction. Please remember that part. Don't just write 9.2%. Don't just write 9.2. If you are punching it on a calculator, it has to be 9.2% over 4 so that you do not lose marks. Otherwise, we lose marks when we substitute wrongly there. Put the exponent, we'll get our effective interest rate as 0.0952229. It continues like that. But we want to find the effective rate for the annum. You will multiply the effective interest rate I by 100% to convert it to a percentage, and that will give us 9.52%. So that is the effective interest rate for that one. That is the effective rate for that one. So you are comparing the effective interest rate, which is 9.52%, to the 9.5% for the whole year. So you'll realize that 9.52 is greater than 9.5. So it would mean when you conclude 9.2% per annum compounded quarterly is a better rate of investment. Now, let's move on to the next example. Right. I have two of them, A and B, and I will ask you to answer these in 4 minutes. Let's quickly answer. We are converting 10% per annum, which is our nominal interest rate, to a effective interest rate. This is 10% per annum compounded monthly. You know how to manipulate that. And then part B, we convert an annual effective rate of 13.5% per annum to a nominal interest rate per annum compounded quarterly. 4 minutes. Let's quickly attempt the two questions. Okay, welcome back. I hope you were able to get the solutions there. For A, we are converting a nominal interest rate of 10% per annum compounded monthly to an annual effective rate. Now, it means our I nominal, we are going to get this as 10%, or we can write it as 10 over 100, or we can write it as 0.1. And then our M, this is compounded monthly, so our M is going to be 12. And we are going to use the formula EFF is given by 1 plus I nominal over M to the power M. I've moved the 1 to the other side to make my life easy. Then I'll have I effective is going to be 1 plus, I can use any of the versions. Let me use 0.1 over 12 to the power 12 minus 1. You can quickly punch this on your calculator, then the solution will come out, and this is what you would get. So we got our solution as I effective is equal to 0.1047. That's our effective interest rate. To convert to a rate, we multiply this by 100, and this will give us the effective rate as 10.47%. So if you invest at 10% per annum compounded monthly, it means at the end of the year you would have gained an interest of 10.47, not only 10% per se. Now, so we got our rate as 10.47%. Let's move on now to the solution for part B. Now, for part B, we are supposed to convert an annual effective interest rate of 13.5% per annum to a nominal interest rate per annum compounded quarterly. So where do we start? Our effective rate, it's going to be 13.5% or 13.5 over 100, or we write it as 0.135. Our M is equal to, it's compounded quarterly, so our M is going to be 4. And then we do not have our nominal interest rate. That's our question mark. From the formula, we know that our I effective, it's given by 1 plus I nominal over M to the power M minus 1, like that. So there's some bit of algebra that we need to do here after doing our substitution. Let's quickly check. Now, our solution will be like that. Our M is going to be 4. We substitute and we will get this. Remember, this is exponential. When we want to take off the exponential, you know that it has to become a root. So we are able to see that it will be 1 plus 0.135 to the power 1 over 4 minus 1. We multiply this by the 4, which is the denominator there, and we make the I nominal the subject. And then from there, we will get our I nominal as 0.1287, and it continues. There are some digits that I did not write down, and the rate becomes 12.87%. Now, we move on to the other concept that we use a lot in financial maths, timelines. So we know that a timeline helps us to visualize the timing and the amounts of cash flows. Cash flows, those are our deposits and withdrawals. And also sometimes you'll be told that the interest rate changes. So during the investment, and that will help us to see what is actually happening on our transactions, on our investment. So as example 1, we're given that 10,000 rands is deposited into a savings account. 1 year later, 2,500 is withdrawn. We need to calculate the value of the account at the end of 4 years if interest is calculated at 12% per annum compounded quarterly. So now, because now there are deposits and withdrawals, it means we have to cater for those. Remember, if there is a withdrawal before the end of the investment, it means whatever is withdrawn on the investment will go with its interest that it was supposed to accumulate for that remaining period when it was withdrawn. Now, we are able to say, draw what we call a timeline. In an exam, there is no mark for a timeline, but a timeline normally helps us to visualize what is happening, and it helps us to interpret the question correctly. So we are saying, so I'll say our time at T0, we are having 10,000 rands. And after 1 year, so I'm going to use a negative sign for the withdrawal. 2,500 was withdrawn. Those in accounting, I know they use brackets somewhere. And then we want to find how much will be in the account at the end of 4 years. So I'm able to see that this 10,000 is going to accumulate interest for 1 year. And then the 10,000 plus the interest will give us the total amount at the end of year 1. Then we are going to take out the 2,500. Whatever was the final amount for 1 year, we take out 2,500. That becomes the principal amount for the remaining 3 years. So that is the A that we want to get. After this withdrawal of 2,500, how much will be in the account at the end of 4 years? Now, I've used T0 as the number of years, but remember now, because it's compounded quarterly, it means whatever we are going to be substituting into our formula is going to change accordingly because of the compounding. So I have drawn a timeline that speaks to this question where we are saying, remember, for the first year, the interest is going to be awarded 4 times. So at the end of the first year, the interest would have been awarded 4 times. That is why I have T0 to T4, because I'm showing where the interest 4 years. We know that to get this, it's N times M, isn't it? 4 times the quarters, which are 4, will give us the 16 that I've put on the timeline, so that I'm able to manipulate my timeline the way I want. Now, we also know that our interest is going to be 12% per annum compounded quarterly. So the I that we are going to substitute, it's 0.12 over 4, and the M is going to be 4 like that. Let's quickly check what our solution will be. I will move very fast. Now, there is our timeline. So it means at the end of year 1, we are going to have our principal amount as 10,000. Our interest will get 11,255.09. We will make the withdrawal of 2,500. So at the beginning of year 2, 8,755.09 will be in the account, and this becomes the principal amount for the remaining 3 years. And we are saying this will give us the n times n for the remaining. So it's 3 times 4. This means whatever we're going to substitute there, it's going to be our 12. Our interest is going to be that one. And we are able to get our answer as at the end of year 4, we'll invest this for 3 years and we substitute into the formula and get 12,482.66. This is the amount that will be in the account at the end of the 4th year, including the withdrawals that were done. We move on now to the alternative method of answering this question. So we said we first of all calculated the A for the first year, did the withdrawal, and then had the principal amount, which gave us 12,482.66 as the final amount that will be in the account at the end of the 4th year. Now, method 2, we are having our timeline like that, but we make sure that we pull everything to the end of the period. So, as you can see, the 10,000 that we invest at T0 will be in the account for the duration of the whole 4 years, and it will accumulate interest for the 4 full years, and it will be awarded interest 16 times because of this 4 times 4. So our n times m for that one will be equal to 16. Our I remains the same, it's 0.12. Our m is going to be 4 for the 10,000. Then we are making a withdrawal of 2,500. That 2,500 is going to go with the interest that it was supposed to accumulate if it was in the account. So the interest is the same as what we have for the 10,000, but what is changing now is the n times m, which will be 12. So we'll use the formula. A is equal to P1 plus I over M. N1, remember, it's for the number of years for that particular 10,000, which will be 4 times 4. And then minus 2,500. Our 1 plus I over M remains the same. What changes? The N2, that will be our N2, which is 3 times 4. And you will realize that we are getting the same amount of 12,482.66. So it depends with you learners which method you are comfortable with. So when given such a question, just draw your timeline to help you understand the scenario. From there, you choose the method that you are comfortable with. For both methods, we are getting the same amount of marks. You will see as we answer the questions that will come later on. Now, there's something also that we need to discuss, which is our depreciation. We know that depreciation is a decrease in value of assets, goods, and services, and depreciation occurs in 2 ways. We have got simple interest formula depreciation, which is also known as straight line depreciation. The formula is given there. Simple interest, where there was a plus, we are now replacing it with a minus. On the reducing balance depreciation, it's the same as the compound interest formula, but we are changing the operation sign now. Instead of a plus I, it's a minus I. You are able to see that A is the final depreciated value, P is the original value, I is the depreciation rate per period, N is the number of periods. They are the same here. Please note that depreciation, our N is always in years. Our N is always in years. It will not change. We will not use the changed compound interest formula for depreciation. Our N remains as years. Now, there is another concept of inflation, which we did not discuss, but we know that depreciation, its opposite, it's inflation. Goods and services also accumulate in value as the time goes by. I hope you have, if you listen to news, you will be told that the inflation rate, when there are salary negotiations, where we are told that it's a inflation +1 +2. So it means we, as workers will be demanding a percentage increase which is more than the inflation rate. Otherwise, whatever they will be getting will not benefit them at the end of the day. So inflation, goods and services will increase in price. If we buy a car today, the same car after 5 years, when they manufacture it, the cost of manufacturing it will not be the same as the cost of manufacturing it now. Hence, we'll say that will be the price of the car, including taking into consideration the inflation rate. Again, the car that we buy today, after 5 years, will not be having the same value because it would have depreciated in value. So those are the things that we need to know about this. Now, let's look at straight line depreciation. Now, look at the words that come on our questions. Normally, they will tell us whether it's straight line depreciation or reducing balance depreciation. A company has computer assets that depreciate at 8% per annum on a straight line method. If the initial value is 200,000, determine the value of the assets after 3 years. So what do you realize? It's depreciation. So because straight line depreciation, A is equal to P1 minus I times N. Again, we need to note that the principal amount in this case should be more than the final amount. So depreciation, A is less than P. For investments, A is greater than P. So those are the things that you should remember as you are answering these questions so that you substitute correctly. So if you're answering a question that involves depreciation, you find your final answer. For example, you are supposed to determine the value after 5 years and you get the value which is more than the initial amount. Note that something would have been wrong there. So we'll use the depreciation, straight line depreciation formula. We substitute. So if the computer assets are worth 200,000, after 3 years, they will be worth 152,000. Again, if we are to draw a graph, you will find out that the value versus the number of years, our graph will be a straight line having a negative gradient like that. So that's straight line depreciation. That will be our answer. Let's check this one. We have a car which is worth 125,000. It depreciates at 6.5% per annum based on a reducing balance. Determine the value of the car after 4 years. So the only difference now, our A, we don't have. Our P is going to be 125,000. Our N is going to be 4. We are using A is equal to P1 minus I all to the power N because it's depreciation. We are going to substitute this into our formula, then we'll get our solution as 95,533,67. So a car that is worth 125,000, after 4 years, if the depreciation rate is 6.5%, after 4 years, it will be worth 95,533.67 rands. Now, let's try this example. 2 minutes. A photocopier purchased for 22,000 depreciates after 5 years to 10,000 at a reducing balance. Method: what is the rate of depreciation? Remember, we are not always calculating the values of A and P. Sometimes we'll be required to calculate the value of N, sometimes we'll be required to calculate the value of I. Let's quickly answer that one. 1 minute. Welcome back. Now, let's quickly check how we have fared on this one. What did you get as your solution? Is it around 16%, 12%, 20%? Let's check and see. Right? We are using that formula. A is equal to P1 minus I to the power N. Remember now, we are going to substitute our A. It's going to be, final amount is this 10,000. So our A is going to be 10,000. Our principal amount, it's going to be 22,000. Let's substitute. We'll get our N is going to be 5. Our R, we don't have the rate. So if we substitute into the formula, we are going to have 10,000 is equal to 22,000. 1 plus, sorry, it's supposed to be a minus, not a plus. What am I doing? 1 minus I to the power 5. Then we'll get this as our solution. Because we want I, we will divide by 22,000 on both sides, and we'll get 5 over 11 is equal to 1 plus I to the power 5. So to manipulate that, we know that we will find the fifth root on both sides, or raise both sides to the power 1 over 5. And that will give us 1 minus the fifth root of 5 over 11, and that will give us 0.1458. So the rate as a percentage becomes 14.58, because we are just saying this times 100%, and that will give us 14.58%. If it is to 2 decimal places, because that's what we normally have, round off your answers to 1 decimal place or 2 decimal places. To 1 decimal place, it will be 14.6%. To 2 decimal places, it will be 14.58%. We move on now. Now, remember, when we are answering questions, we need to read and understand the question. Step 2, you underline the key terms you have seen. If it's an investment, we know it's compound growth or simple growth, simple interest growth. The duration, depreciation, etc. Those are the kind of words that will help you determine the formula that you are going to use. You interpret the question, extracting key information. You have seen I'm always listing my information that I'm given in the question, my I, my P, my I, and putting a question mark to what I don't have. We select the correct formula, we substitute, and we manipulate accordingly. Now, let's look at an exam question. I will give you 8 minutes to answer these 3 questions. 8 minutes. Let's quickly answer those ones. Right, welcome back. I hope you enjoyed answering this one. The first part, we are having a tractor bought for 120,000, depreciates to 11,000. So here our P is 120,000. Our A is going to be 11,090,41, our A, and our N is going to be 12. You see, reducing balance method. So it means our A is equal to P1 minus I to the power N. And then we should be able to get our I. Let's quickly show you the solution. So we are going to substitute into the correct formula. You get 1 mark. You are also going to use your manipulation to get there. You'll get your I as 17,0,17999, and then we will get our solution as 18%. So we get our 4 marks there. So sometimes the mark that I've awarded on the first step, it's awarded for choosing the correct formula. So reducing balance, choosing the formula, substituting and manipulating, you get your marks there. So if you got 18% as the rate, then you have your 4 marks there. Let's move on to the next one. It says calculate the effective interest rate if the interest is 9.8% per annum compounded monthly. We know the formula to use. I effective is equal to 1 plus I nominal over m to the power m minus 1. Then we are going to multiply this by 100 to give us the effective interest rate. When we change it to a rate, this I becomes R there. Let's quickly see the solution. And we should get our rate as 10.25%. So we will get the correct substitution. Correct, we'll get 0.1025 and the rate will be 10.25%. Then we get our 3 marks there. We move on to the next one. We are told that Mrs. Pillay invested 80,000 into an account. The interest now is changing. Remember the ones that we did, you would find out that we only did where there are withdrawals and deposits. So sometimes the interest rate is the one that is changing, but we still need to calculate the amount in the account at the end of 7 years if no further transactions occur. So we'll come up with a timeline, which is on the right hand side there. You are able to see that for the first period of 4 years, you are able to substitute from T0. We have our 80,000 here. We don't know how much will be in the account at the end of 7 years, but our I that we are going to substitute into our formula is that one. Here, the interest is compounded quarterly for the first 4 years, so meaning our N that we are going to substitute, or our, let me use N1, will be given by 4. The interest is compounded quarterly, it will be 4, meaning that will be 16. We can have our N2 there. It's 3 years, but the interest is compounded monthly, meaning for our N2, this will be 3 times 12, giving us 36. So we can use the formula of our compound interest, where we are saying the final amount at T4 will become the principal amount for the remaining 3 years there. So we will get the final amount, which will be 107,689,1465, which is the final amount. I will call it A1. After 4 years, that becomes the principal amount for the 3 years, and that will give us our final answer as 141,768,60. That is the first method that we can use. Or alternatively, where I've used N1 and N2, you are able to see that you can use that formula where you have your I1 and your I2. Remember, you are just saying whatever the answer that we got from here becomes the principal amount for the next period. You don't need to evaluate it first. You can just punch this on your calculator and you'll get the answer straight. So you choose whichever is comfortable for you, then you get your solution like that. So we have looked at a timeline. We can quickly take a picture of this question. I'll also give you time to take a picture of the solution, and you are going to mark yourself later on because time is no longer on our side. So you have captured the picture. The solution, we are going to have our solution as that. This is the easier one. You can see that the 30,000 will be in the account for 8 years. That is why here we are saying power 96, because it's compounded monthly and for over the period of 8 years. So we are going to have 8 times 12 giving us the power 96. Remember, we are pulling everything to the end of the period. The 10,000 that was withdrawn after 3 years will be in the account. It will go with the interest that it was supposed to earn for 5 years. Hence here we are saying power 60, but we are subtracting. And the 10,000 that was deposited, it will earn an interest for 3 years there. That is why our power is 36. And then we get our solution as 48,708,61. But now we want to see the difference. You will realize that for the first period, you will get 48,708,61. We subtract the amount that she gained without these transactions that occurred. Hence, there will be a difference of 1,681,46 if there are transactions that occur. Now, yes, so we are able to use that method. I will pass this because we have already discussed it. And right, you can take this one as well as a picture. I will show the solution just now, where you are doing a comparison of the two. And for Kuta, you will find out that the amount that he will get finally is 6,926. And for Tabo, the amount that he will get is going to be 6,905. So meaning you are comparing the two. Whoever gets the highest money, it means it will be a better investment. Now, we will not be able to go to the homework part, but yeah, time is no longer on our side. So, in summary, we have learned about the simple interest formula, which is given by that formula, and we are told that it depends on the initial balance or loan, and hence it remains constant over the given time. Like I said, simple interest formula can be used on hire purchase as well to calculate the total amount. Compound interest formula, we have seen that interest is based on every amount that is in the account, and remember, the interest formula can also be used for inflation. We have also looked at nominal interest rate as well as the annual interest as the effective annual interest rate, and we are able to see that it will change according to the compounding periods, and we get the effective interest rate. Now, we use a timeline to help us understand and visualize and interpret the problem easily and correctly, and we are able to answer financial maths problems. Please, let's practice more, and we should be able to get these marks. Practice makes perfect. Thank you so much. Please let us keep safe. We know that we are no longer putting on masks, but COVID is still with us. Let us be safe, and we prepare thoroughly for our preliminary examinations. I wish you all the best, and let's keep on keeping on. Have a good afternoon.